everyone. Today we're going to learn about how to solve a system of equations by graphing. There's some vocab words we are going to need to discover. We're going to learn what a system of equations is. We're going to continue practicing graphing lines in standard form, in point slope form, in slope intercept form. I want us to be good at all of them so that we don't have to spend extra time converting from one form to another. So let's start with a warm-up. Hey, remember, whenever I give you a warm-up or an example problem, I want you to pause that video, try it out, show yourself that you can do the whole problem, or maybe you get stuck somewhere, and then when I'm showing my explanation, you repause the video, try it out, and we'll all get to the finish line together. So graph the following linear equation, 6x plus 3y equals 18, using one of the methods we have discussed so far. I also want to know what the x-intercept is, what the y-intercept is, and the slope. So pause the video, try it out, and when you're ready, unpause the video, and we'll look at the answer. Okay, so let's look at this problem. I'm going to show you a few different ways that you could have done it, and you'll check to see if you got the answer correct. So I'm going to keep the equation in standard form the first time I attempt this problem. I'm going to find my intercepts. Standard form, we remember, is great for finding intercepts. X-intercept, put y as 0, set y to 0. We solve for x, and we get 3 comma 0. X was 3, y is 0. That's the x-intercept. When we want to find the y-intercept, we make x 0, and we solve for y, and we get 0 comma 6, because we get y equals 6. So that's how you find the x and y intercepts. I don't need to graph it to find the x and y intercepts. But if I'm not fluent with that one yet, maybe I like to put it in slope-intercept form, y equals mx plus b. So for this one, I could subtract 6x. I could divide by 3 on both sides, divide everything by 3. Make sure you divide the coefficient of the x, and you divide the constant by 3. And you get y equals negative 2x plus 6, where m is our slope, negative 2. B is our y-intercept, which is 6. Notice how the y-intercepts match up. No matter which way I do this, the y-intercept is going to be the same because it's the same equation. Now using either the slope and the intercept or the two intercepts, I can graph. I strongly recommend, if it's in standard form, just find the intercepts, graph that way. I already found the slope, but if I didn't have it, I can find it from the graph. I go down 6 over to the right 3, so negative 6 divided by 3 is negative 2. And that matches what was in my equation. So depending on what the question's asking, we may have to graph it. We may want to find the intercepts. We might want to find the slope. Or in this problem, I wanted you to do all of it. I want you to practice and be good at any question they could ask. Now moving on, we're going to take and apply this to a system of equations today. Now what a system of equations is two or more linear equations working together. In this chapter, they're going to be linear, and in future chapters, we're going to have lots of different equations. Some that are linear and some that are nonlinear. So the system is just two or more equations working together like a machine. Got 2 steps, maybe 3 steps. Now a solution is whatever coordinate point, and there could be multiple, that make all of the equations true. So since we're going to be dealing with x, y coordinate points, we're going to have an x, y value that we could substitute into every equation and make it true. And one way we can do this is by graphing and finding the intersection, where the 2 lines meet on the graph. So let's take a look at an example together. Here's a 2-equation, 2-variable linear system. 2 equations, 2 variables, x and y. It's linear. Both of these are standard form for a line. And I want us to be comfortable with the vocabulary. When I ask you, how many equations do you have? That's going to help us figure out, well, how many lines should I have on my graph? Is it linear? Should I graph straight lines, or are there going to be curves involved? All of that's going to be very important. So we're going to look at this two-equation linear system. And first, we're going to say, can we find the answer? What's the coordinate point that makes both equations true? So I want you to think about an x and a y value that make both equations true. So I tend to hear people say, okay, I can do this top one. I can pick two numbers that add to 7. Well, 5 and 2, 5, 2. And that works, except it doesn't work for the second equation. So that's a problem. Then I always have other students tell me, okay, I know that x minus y equals -1. Maybe I'll pick 4 and 5. 4 minus 5 is -1, but 4 plus 5 doesn't equal 7. And sometimes the answer might be a decimal or a fraction. It could be positive numbers, negative numbers. And sometimes students guess all day. Okay, and brute force guessing check is valid, but it's not efficient. Eventually, you'll see that if I put 3 and 4 in, 3 plus 4 is 7, and 3 minus 4 is -1. And that's the only coordinate that would work. Now, I could do it the guess and check method, but I could also do this graphically. So to solve by graphing, I want to graph the two lines on the same graph. I want to be accurate, and then I can find where they intersect. So we're going to graph both of them. I'm going to use the intercept method, the x and y intercept method. But I could write it in y equals mx plus b. I can write it in slope intercept form too. I find the information that I want to graph for both of them, and then I go ahead and graph it. Get your graph paper out. Take and make straight lines. And you'll notice that 3, 4 is where they meet. They only meet at one spot. You can't have two straight lines meeting at two spots, because that would mean the graph would have to curve or do something weird, and that's not going to happen. We're doing linear systems. Graphs are going to meet at a point. There are other cases which we will talk about shortly. And then I write my solution. If it asks what's the answer, the solution to the system, it's 3, 4. The answers where they meet, you have to write that down. Just don't say, well, here's the graph, you figure it out. You want to tell your reader, okay, I know the solution's where they meet. Now I want you to try some of them out. I want you to pause the video. We got equations in slope-intercept form and standard form. I want you to practice both methods of graphing. Don't restrict yourself to just, well, I only know how to graph y equals mx plus b. I want you to be able to graph in any form I give you. So pause the video, and then when you're ready, unpause it. I will show you the answers to these 3. Okay, so let's take a look at each case. The first case, they meet at a point at 4, -1. We can put it into y equals mx plus b. We can graph using the intercepts. Okay, the intercepts here are pretty nice. This one, x-intercept 6, 0, y-intercept 0, -3. Okay, so nice x and y intercepts. I can graph it that way. The second case, okay, they meet at 0, 2. If you put these both into y equals mx plus b form, okay, you could rearrange it. Now, I don't know if my graph is accurate because I'm already looking and seeing that this has a y-intercept of -2, so that's going to tell me that this one is wrong. So I'm going to put a giant X through it. Okay. I'm going to regraph it. Okay, I'm going to ignore what's on my screen and say, okay, that don't look right. And this is an example of how to immediately check. So this has got x-intercept of 3, 0, because I cover up the y, 0, 2. So this red graph looks good. That means the blue graph, uh-oh. So I think I did, when I graphed this, ignored the negative sign. So I can easily correct that and say, let's put a point at the y-intercept of -2. And then I can make a slope of down to right 1, down to right 1, down to right 1. And now I see the actual point they meet at is -3, 4. Okay, so I go and look and I'm like, oh, that answer don't make sense. And I could even put 0, 2 into both equations. And if it doesn't make the equations true, then it's not right. That's how we know. That's how we know whether the answer is right or wrong. We don't just check with the answer key or say, well, I hope. We can check our own work. Now, this last case is more interesting, I think. Now, I get students telling me all the time, Mr. Minowitz, you screwed up. Okay, you gave us a system of lines that doesn't cross. At which I reply, that's possible. There's plenty of lines that are parallel. And what this means is that there's no solution. There is no point. You can come up with as many as you want. There is no xy coordinate that's going to make both of the equations true. Okay, these have same slope, different y-intercepts. Parallel lines do not have a solution in a system. So, systems of equations. When we're solving a system of two linear equations and we graph them, a lot of times we're going to have this first case. The line intersects once. The solution is that coordinate where they meet. We also saw we could have no solutions. Okay, lines are parallel, don't touch. And situation 3, which we didn't see in any of these examples, are the lines are the exact same. They touch everywhere. Okay, they can be written in slightly different forms. They can be written in the same form, but they have the same y-intercept, the same slope. Everything about them is the same, and that's how we have infinite solutions. So we'll continue practicing graphing, and we'll be able to see that we can solve systems graphically.